Coroneos 100 integrals number 46. Okay, so we're going to integrate e to the power of x times by sine 2x. Alright, so we've got a product of two different functions together. Clearly, this is integration by parts. Okay, so we're going to use the method of integration by part to do the question. So to do this question here, I'm going to let u equals to sine 2x. There's no point to letting u equals to e to the power of x because the derivative is just e to the power of x. You're not going to change anything. So if we let u equals to sine to the power of sine 2x, u dash is going to be 2 cosine 2x. V dash is equal to e to the power of x, and v is equal to e to the power of x. Alright, so we need to just multiply these two together, and then we can use integration by part. We end up with e to the power of x multiplied by sine 2x. That is just a product of these two, alright, which is u times by v. And once we finish that, we need to minus the product of u dash and v. So we need to minus the product of these two. And that gives us 2 integrate e to the power of x cosine 2x dx. Okay, so obviously we can't finish this question this way. We still have this one to do. But hopefully you realize this. It becomes a loop, okay? It becomes, we're going to eventually end up with another expression e to the power of x sine 2x. So where we actually can move that expression, the same expression, to the left-hand side, and and we can use them in algebra to simplify these. Okay, all right, so then the next step we do is we need to use the integration by part one more time. This time I'm going to let u equals to cosine 2x, and u dash is equal to minus 2 sine 2x. V dash is still the same, and v is still the same. All right, we're still going to still using the process of integration by parts, but just have to be extremely careful about where you need to put a bracket. We're going to put a bracket here. So that gives you e to the power of x cosine 2x minus, okay, now minus, there's another minus here, so therefore that becomes a plus. 2 integrate e to the power of x sine 2x dx. Okay, so that's what you get. Now, once we have finished this, we can now simplify by expanding it. All right, just be very careful about expanding. Minus 4. E to the power of x sine 2x dx. Alright, so once we have finished that, then all we can do is we can actually call this one, we can call this one as like, I, okay? And then this is the same I here, as you can see. So if we just let I equals to that, then we end up with I equals to e to the power of x sine 2x minus 2e to the power of x cosine 2x minus 4 times by I, because they are exactly the same. So then what we can do now is move that 4 times by I to the right-hand side. So to the left-hand side, so you end up with 5i is equal to e to the power of x sine 2x minus 2e to the power of x cosine 2x. All right, and in order for us to actually find out the I, which is the original question, so you move the 5 over, so that gives you 1 over 5 bracket e to the power of x sine 2x minus 2e to the power of x cosine 2x plus c at the end. All right, and that becomes the final answer to do the question here. So I feel like I probably need to have a plus c here as well at the end. All right, so this is a really tricky question. You need to use 2 applications of integration by parts to do this question here. We're not really solving this question directly. We're actually doing that, so that becomes a loop. As you can see, they are identical to each other. So we can move this term over to one of the sides, and we can create an extra, 5 lots of the I here. And then we can actually, find out the answer for each individual original question, which is each individual I. All right, thanks for watching.